Hello, DerbyCon. Well, I'm here to talk to you guys about GFCIs and more like solenoids, so I was thinking maybe the title should have been something like, I think I'm solenoid. Complicated. Yeah. So I might be a new face to some of you guys. My name is Maggie, Jauregui, and I've been doing security for about 3 or 4 years. About 2.5 in Mexico doing graphics driver stuff, and about a year and a bit up here in the US doing mobile wireless product pen testing. I'm from the mystical, magical land of Mexico, and if you've never been, you really should make a point to go at some point. It's close, it's cheap, it's amazing food, people, and I'm having trouble figuring out why I ever left, honestly. So when I'm not hacking or doing techie stuff, I do more adventurous, outdoorsy, things. Disclaimers. Details. I'm a dancer and a climber and other things. More artsy things. Yeah, so disclaimers. Typical, my research and ideas are my own and in no way, shape, or form represent my employers of past, present, or future. And this was just something I kind of tripped over. Not something I went to school for, or nothing to do with my job whatsoever. So any suggestions or corrections are awesome and welcome. So now time for the story. So I recently moved to the States, and I was dating a certain guy who had an awesome idea, and he said, you know what, we should communicate through radio. And he bought a couple radios, and we lived in neighboring complexes, and he thought, this is going to be awesome, we're going to save so much money. I'm like, we have unlimited talk and text, but that sounds great, babe. So we got the radios and enough batteries till, like, kingdom come. And we never really synced to when we were going to use them. One day we were going to go out, and I thought I heard something, I thought I heard the radio beep on the other room, so I walk in there, and I go, hello, hello, is anyone there? Nothing. So I come back to the room where I was doing my hair, and I click the call button of the walkie-talkie to make it buzz on the other side, and the GFCI on the wall, which is a little black box with the red and white buttons, like vibrated out of control, made a horrible sound, sparked, and smoked. So then I grabbed my phone and was like, oh my god, you gotta get over here and see this. So I go to and for some reason I thought the device itself was bad. And so I went and bought another one, same thing happened. But then I realized the devices actually keep working. Like nothing. So that's where this whole thing started. And then we needed supplies, so we like to thank Goodwill for their supplies. And so we went to go get radio licenses and the antenna and radios and sockets, because started playing with those too, within my own house with the same radio and then with a better radio, and we realized we could play with those too. I could do one of two things. I can either just switch them off, trip them, or well, I'll go into why that happens, or I can permanently disable the GFCI to where it never works, but it's wired shut. So the circuit is wired shut and it keeps working like it's normal. It's no longer protected by a GFCI. So yeah, and I was talking to people that I work with about. It's probably better. Yeah. So to people that I work with about this thing that I had been looking into, and he said maybe you should look into AFCIs as well, and that kind of put the picture together, where we have in our house we have GFCIs built into the 90-degree sockets on various devices. And then on the plugs in the wall required by code. And then also we have the rest of the house protected by AFCIs in your garage or wherever that is. And they have two different purposes. The purpose of a GFCI is to protect you from electric shock, and the purpose of an AFCI is to protect your house from catching fire. And yeah. So code requirements. GFCIs are usually required anywhere where there's contact or potential contact with water. So your kitchen, your bathrooms, indoor wet locations, hot tubs, pools, outside, anything crawl spaces below grade level, laundry areas. And AFCIs pretty much protect everything else. So dining rooms, living rooms, libraries, dens, closets, etc. And some overlap, like the kitchen and the laundry areas. The what? Sun house? Sun pumps. Ah, yeah. Water, yeah. So the way the FCI works. So the little transformer, there's a little ferrite electromagnet with a wire that goes around it, and according to the right-hand rule, okay, yeah, so according to the right-hand rule, if the field goes one way, there's the two wires, the live and the neutral, and they're bound around the little transformer in opposing ways. So they're supposed to cancel each other out. The same amount of current that comes in is the amount of current that comes out. And if it notices a small difference between them, then that current has to be going somewhere. It detects it. I think it detects from 5 to 30 milliamps, which is enough to go to your card and cause ventricular fibrillation, which is when your ventricles, instead of contracting the way a normal heart does, they spaz out and go into shock. And it has to do it quickly enough for that not to happen, so between 25 and 40 milliseconds. And this is the way it works. There's a shunt that just physically moves and separates it, and so it measures what goes in, what goes out, and there's the test button that forces two of these to go the same way, and then it forces an imbalance to cause the trip. To prevent this, you from completing and grounding, completing the circuit by grounding it. Thank you. So yeah, basically it works like this. And there's plates, so the prongs that go into the wall are connected to these, and then on the bottom there are plates that connect to the wire that goes to the device. So physically, when you push the red button, you push them together, and the white one pushes them apart. So it's mechanical, electromechanical. And this is the solenoid. It's a little, I forget the proper term for it, but it's a little bullet that goes either in and out, and it's controlled by the field on the solenoid. It has some other components as well, and the GFCI power outlets. The GFCI power outlets, for the most part, we only would be able to do something with from a very close range, unless we followed the wire. So we realized that if you target a wire, or if someone targets your wall as a whole, they could potentially get to the outlet even though they're not physically pointing at your wallet. So the point was to try to find ways that someone could potentially hurt you or do something with this. When we went to get things to experiment with, and all we could find that had a GFCI plug at the store were hair dryers, I got asked, so we're targeting women? It's like, no. You know, the power outlets work too, so what else could we do with this? I mean, how could it be bad? AFCIs, art faults. These are much more complex pieces of electronic that protect you against short circuits and overloads and overheating and even bad devices in your house, and they do wave processing to make sure that it's smooth and there's no arcs that shouldn't be there that could potentially cause a fire. And it also protects you from ground fault. So the same little mechanism that we saw in the GFCIs. So we weaponize this. Yes. Yes. Little purple laser there. But this actually didn't work because there's a whole bunch of metal in the hairdryer, so no. And all I can say about my antenna is this. Legal had a problem about me disclosing a recipe of how to do bad things by Maggie. Instead, we're trying to be You're welcome. So, some demos, some videos. This was, I guess, the first thing I saw. There was some smoke. That's my dog drinking water. Oh. It vibrated. Yeah, you heard the vibrate. And that's the solenoid moving within its little. So it gets better. Here you can see the spark if you're careful. That was return. That was slow and kind of. Not very far. Pretty close. Yeah. With the antenna, I can get it up to, I think the most it was like 4 or 5 meters. So, huh? Yeah. So the outlets, like I said, mostly we just tripped. So we trip them from front, from side. You can see the little light turning off from the back. And we realized, and I swear I was not trying to do this, across walls. So I was trying to target the one in my own kitchen, and we heard something buzz horribly, and I was like, what is that? And we stopped immediately. We didn't, it was not promising. Yeah, it's not a lot of power.
It's not very much for just. Were you running on the family radio band when it split?
Huh?
Were you using a walkie-talkie or were you using a ham radio?
At the first time, it was just a walkie-talkie, but then.
So 420 or 426.
Oops. You can guess. And this is a pretty bad example of the faraway one. Sometimes you need to keep going and going until eventually it would blow up. And these are all with the case closed, but then we thought to open it and see what was going on inside, which is a lot more exciting. Check out the button. Yep. This one was in my hotel in Vegas. My dad. I couldn't see that. I don't know why. When I present this, it's so slow. But you'll get to see it live. So today I thought, why don't I do like a few of them together at the same time? So yeah, I got one of those spaced out plugs where I could put 4 of them and line them up so they would be on the line of my directional antenna. This was this morning. So we sacrificed already 4 hair dryers to the demo gods. Yeah, some of them are more stubborn than others.
So what does your room smell like?
We opened a window because we were afraid. The last one. So this is what the GFCI looks like when it's burnt, or the solenoid. The plastic casing around the wires melts, and then it stops being a solenoid. Yeah, some of the components explode. They overheat. Because a solenoid is meant to work once, right? Like when you push the button to buzz someone up a building, you mean to open the door and just, now it's open. You don't have to sit there and keep pressing it. And if you did, you'd probably overheat the components like I'm doing with my radio.
Do you know what the thermal limitations of those devices typically is?
No, probably not very much.
Have you pointed this at any other kind of electronics to see what we got?
No, but it seems like it has a ton of different applications because there's solenoids everywhere, right? There's solenoids to lock doors and fuel valves and to start cars to.
Let's try that
So.
door. Those have motors in it. Let's try it on this boy.
Yeah. Huh?
Is it enough to break a
Sorry, I'm sorry. Deviant? Definitely. I'm super excited to keep trying to look what else we can, and because it seems like there, referencing an article later that Spectrum released on August 25th about how even networking equipment is vulnerable to radio frequency interference, and their burnt out components look exactly like mine, and the PCB boards are just Belkin instead of, Revlon. So
If you mess with the timing on certain motors,
I don't know. I would guess.
Can you ignite thermite?
I don't know.
I can make them out of a loose can of rusty.
So, yeah, this is what the components, when they're blown up, look like afterwards. The little SCR and the capacitor. And so I found this video online researching AFCI. So, second 22. They use an antenna on the top of another house, pointed at the house, with a garage door open and the AFCI is exposed. And it's really, really slow, sorry. So I think they're just showing the antenna on the top of the house, which might be somewhere like there. And then, yeah. And over here, probably. And then 547. And these guys use a lot more power than I do. These are AFCIs, yes. And you can't see it because it's freaking slow for some reason, but quite a few of them actually.
did it shut off the main?
Shut off what?
Did it shut off the main switch?
I don't know. See? You can see like a lot of them. So, yeah. So my idea at this point was, how can this affect people? Because if you can, from outside someone's house through a window, turn off someone's blender and you denial of service their guacamole, then maybe that's not, too annoying. Although, to me, someone just messing with my hair schedule would really be a high-severity bug. Yeah, I wasn't sure. But then I started to think about people who are maybe elderly and are plugged into things that shouldn't be turned off, or, and maybe things that are, and this could be accidental or purposeful, So, I got to the hotel here. Yeah. Shielding, no, but that's one of the suggestions, right? To think of, just shielding everything, shielding the wires and the components of electronics in general. So, exactly, EPSI the world. So I get to the hotel here, and I don't know if I just don't go out a lot, or if, but I lay on the bed, and the first thing I see in front of me is the AFCI panel. It's like, oh, let's play with it. Okay. So. Lights out in the room, and with the door closed too. So yeah, even AR, yeah, it's an EM field. So ARL, an Amateur Radio Association, even apologized for their people disrupting other people's AFCIs and worked with companies to try to make them better, but apparently,
Is this
yeah.
part 15?
Huh?
Is this Violet part 15?
No.
No, it must accept all interference. I've done that.
Cool. So, to think of what's going on, resonance. Resonance is like if you ever had a tuning fork. Yes, sorry, English not my first language. And you hit it and you put it up to a guitar, and then the string of the note that it's tuned to will vibrate on its own, and things resonate to their particular frequencies that are defined by their physical properties. So things in the U.S. work at 60 hertz, so that's what most electronics resonate to. And what I'm doing here is shoving the electromagnetic field onto these plugs and activating them. So a transformer captures the electromagnetic field because it has an electromagnetic magnet that focuses them there, and it induces a current by Faraday law. So, yeah. So solenoid comes from solenoid, French, which is solin, pipe, and oid, shape. So it's shaped like a pipe, and it's just a circular, spring-shaped wire. And Faraday's law says that induced electromotive force in any closed circuit is equal to the negative of the time rate of change of the magnetic flux through the circuit. So, and they're everywhere. They're, like we said, they're in locks and valves and dispensers in a whole bunch of industry sectors, and the cars, doors, security, cameras. Yes. Yeah, and the chargers of cars. Yeah. Yeah. Yeah, and the article in the Spectrum actually talks about that, about whether you can go narrow and have just one frequency very intensely, or you can have a range of frequencies and try to find which one the components actually resonate to, because they're not all going to be the same, right? Yeah. So right now I don't do that. I've just been doing with the radio and the antenna, but future work, for sure. And anyone can tell the difference between the ones that are affected by my radio and the ones that aren't?
Also, they look like
They have my electronics design.
made in China.
They have this little chip on top. And the ones that don't, and that just have diodes, aren't vulnerable.
Do you know who makes those chips?
They're Chinese, all of them, pretty much. Yeah.
Yeah, that narrows it down.
Yeah, and they're old. The patents that are vulnerable are old. They're like 1995. So, yeah. Yeah, I found a few, but the most commonly ones that I bought are the vulnerable ones, the old ones. Yes? Wow. I don't know, 10s. 20 maybe. Yeah, for sure. So, yeah, that little chip is a Chinese old thing that I couldn't even find the spec for. But apparently those take both positive and negative current as current, and these ones have diodes serialized so that it never gets over the threshold that you need to reach in order to trigger the solenoid. And these are the things that the SCR that's supposed to just detect a little bit of current and then trigger the shunt, but both of these with a prolonged period of current, then they will overheat and short or explode. And other scenarios is these things are required by code where there's water, but they can also be connected to other circuits where sometimes people, in things I would be reading, would say, like, I don't know why it trips the lamp outside my house, or that somehow you can connect them, and more things would be affected if you connect more things to your same wall socket. So the patents that are affected, I found a few. Half of them are affected, half of them are not. But most of them are these old ones that are affected. So it's a very popular patent, apparently. And I guess maybe it makes sense, or maybe it's cheaper for companies to use the old patents. I'm not sure.
Well, they expire, so it doesn't cost me.
There you go.
Well, they expire after 14 years. So that first one, 1999, it's expired already. So.
Okay, so that makes perfect sense. Yeah, this was my luggage before. TSA was good to me, though. Yeah, so as of relevance, there was news on July 28th about an 8-year-old boy dying on a lake. He was in the water for 13 seconds. My grandfather went into cardiac or respiratory arrest for 6 minutes, and this kid was in the water for 13 seconds. So it was electrocution. He didn't drown. But it was because of a GFCI next to a lake. And so the GFCI appeared to malfunction and continued to run hot. So that is probably the biggest problem. If the GFCI stopped working, if the device would fail opened.
On the KPIs you posted destroyed, they will all fail closed where it just stops. But this scenario is where it fails open.
Yeah.
Back when I was studying my electrical engineering degree, the GFCI was never to save lives. It was just to protect the circuits.
Mm-hmm.
So as a side effect, it helped people to be electrocuted.
Yeah.
So it prevented the house from burning down.
Right. It prevented the circuits from catching fire and breaking. It was not.
But now every one of these things, when you buy them, comes with a big red sign that says, "This could save a life. You're paying a little more, but it's worth it. It's for your safety." Yeah.
If it fails open, it doesn't protect the circuit in the house either.
Hmm.
BS.
Don't die, bro. Just don't die, bro. I just used my credit card. So don't die, bro.
Cool. So, yeah, the Spectrum article about electromagnetic warfare and how because our infrastructure is depending increasingly on circuits that are low voltages, they're affected by high frequencies. So,
Is there any effective way of dissipating high resonances beyond a certain amount? Like you can get something that's a wavelength that acts at low X number of iterations. So like a radio. So you could say, I want to detect this, and I can dissipate energy from a radio. Like
Just the negatives.
so there were a few recommendations from this article to basically Faraday cage all the things, and put cages on the windows and metal reinforcements on the walls to try to put physical distance between people and the devices you're trying to protect, to do safe rooms for the most things that should be protected, to use fiber optics instead of cables, to protect the cables with metal jacketing or yeah. Okay, the detectors. Hmm? Yeah.
After so many iterations of that signal, shut down the circuit.
Mm. Yeah. And that's part of the danger also, obviously, because it's kind of fingerprint free, and although supposedly there are radio forensics and you could match a specific device to the radio signal that emitted. Yeah. Yeah. True, and it's unreasonable, I guess, to hope that everything's going to now change and this huge investment has to happen to every single thing. But it's I guess it's a step in the right direction to start thinking that we have to protect things against EM, or to at least think about it, and eventually the important things will be taken care of. So yeah, the relevance is that this could be accidental or intentional. It's wireless, it's fingerprint free, and it could just be an annoying
Neighbor trolling.
Or it could actually happen at a place or a device that actually matters, and that would be bad. Yeah, and the first thing that the first thing I started looking at was I looked for where they could be found, and I read that a lot of hospitals use GFCI equipment, and a lot of hospital staff communicate through radio frequency, so that was a little scary. But supposedly, according to the code, at least this year, life support is not to be connected to GFCIs, which is awesome that someone thought about, hey, they could accidentally trip and whoops. So, yes. And things have battery and manual overrides. So that was another, that's part of like the recommendation stuff. If you have an elderly person, just be aware that things could happen, and these things can trip for no apparent reason. And so yeah, test your GFCIs often. Update to new patents if you can tell which one you're using and which one you should. Backup power generators for elderly people that are depending on important things to keep them healthy. Batteries and manual overrides, just so just in case you need it, it's there. And Faraday cages for the masses.
Yeah.
So yes, no, some demos.
Start a fire.
See if I have any questions.
So when you start this fire, will we be able to see smoke?
You'll be able to see smoke, but not fire.
Well, if Boris stops vaping, yes.
Yes.
Maybe try electrocoupling into the signals of the opping of so they actually, the GFCI measures the current in, current out. That's how it trip. You could actually electrocouple into the signal.
Maybe we should talk later. It sounds interesting. Yeah.
Hey, cameras have small motors in them to adjust the lenses.
It's a camera.
Do you think?
Yeah.
Oh,
Yeah, the guy in the white
outside.
Yeah, I heard of some guy in a white beater just walked in and he grabbed the camera and he walked out.
Goddamn nonchalant.
It's a camera. It's a camera.
Well, that's horrible.
Burn it.
Oh shit! Yeah, actually.
This, yeah.
And my nuts in mine too. I'm gonna walk out.
Not this one, but the others, yeah. Cool. So,
It might be still on Jersey. You don't know.
this one. Huh?
Actually, that's a valid point. He's nuts.
Okay. So the reason why I'm doing it this way is because we're following the wire. Unless we are pointing like directly at it, this is the example of following the wire, and it's going to get to your GFCI and turn it off.
Does it matter how long the wire is?
I don't think it does. We tried a little bit longer than like this room wide, and it works. But we didn't try much more than that. Do we have to be completely straight? No. I don't know. I guess we'll figure it out. Yeah, I think it might be.
You sure that's that? Well, suck.
Wow.
Pirate radio station. Awesome. That's blossom.
So I guess. Dumb boats.
All right.
No. Or maybe directly at the GFC.
Hold on, maybe the. Did it?
I heard something. And now for some actual blowing stuff up. Reset.
You're hot. Okay. Boris, don't vape. Careful, careful.
Someone want to try? You guys want to try? Okay.
Hold it or shoot it.
Yeah, but all it measures is it's radiation going towards the sensor, and it measures
Is that the one that shoots
water
out?
particles.
Okay, so let's do the.
The other one?
Whoever catches it.
All right.
Shoot at the audience.
All right.
So aim it. Aim it at the audience.
Whoever gets the button
Whoever gets the button
gets a shot.
wins the shot. You catch the button, you win the shot.
See if it gets that far. No sparks?
Yeah, no sparks, but
Okay. And one last.
you have to get the you have to keep the button to claim the shot.
One more button.
How far away was that? Was that like how much is that in empirical? 20 feet? What's that?
20 feet?
I don't know.
20 Israeli feet or something like
I do metric, dude. I don't do empirical. I ain't no Canadian, eh? Can you hold that?
Yeah.
Right, okay.
And the last one.
You are good.
What's that, like 2 yards? 1 yard?
Good 8 feet. Come on, do it. Oh! Boom.
Yes, man, too.
Thank you. And anyone else have any questions? I'll be around.
Try it on the camera.
Good job.
I love the smell of butter.
Smells like magic.
It smells like mystery. I really does. Thank you.